In this video, we'll cover reconstruction of existing public right-of-way. We'll learn when stormwater regulations apply for work in the public right-of-way and how to meet stormwater requirements to the maximum extent practicable. This is a situation where there's a lot of stuff. There's a lot of conflicting infrastructure and uses for this space in the public right-of-way, right? There's pedestrian access, there's signage, there's eateries, there's metro underground, there's bike share, there are all sorts of underground utilities, there's a streetcar. So this space is used for a number of different uses, and because of that, we have to take that into account in the stormwater management design. But that's not to say that stormwater management can't occur in the public right-of-way. It very much can. There are a number of different ways to achieve it. Sometimes you have to get creative, but you can see it can also be used in a way that it provides additional benefits, such as a separation between, in the top left example, the pedestrian and the cycling lanes, and in the middle, there's some stormwater infrastructure that's providing some stormwater management benefit and an additional separation. Can also be used in a bump out that can be used in conjunction with traffic calming measures. So the rain garden serves the stormwater management purpose as well as the traffic and the neighborhood beautification purpose. We talked about in another video the bioretention tree pits. You can see here, this is something that happens commonly where there's a trench drain here that's receiving runoff from the adjacent street into this tree pit and treating that runoff, as well as receiving runoff from the adjacent sidewalk. So it's serving as this amenity in the public right-of-way while also treating runoff from the public right-of-way. There are underground storage, so there are a number of either suspended pavements or structural soils that can be put in conjunction with a bioretention tree pit to achieve additional retention underneath the pavement. And then the pavement itself can also be permeable. So permeable pavement is one of the stormwater BMPs covered in this general compliance training. This can have its uses in the public right-of-way as well. So there are two cases where we have reconstruction in the public right-of-way. So there's projects that we consider type 1 projects where this is reconstruction of an existing public right-of-way where that's the entire scope of the project, right? So this is generally a federal or a municipal project where they're reconstructing a roadway, an alley, a sidewalk, a trail, that sort of thing. The type that we're going to cover in this video is type 2, where there is a private development occurring on a development parcel, and then the adjacent sidewalk or alley, that adjacent public right-of-way down here is being developed. So we're going to cover this situation in a bit more detail because it's much more common and applicable to the general stormwater management plan. So if there's a major regulated project that does not disturb any of the adjacent public right-of-way, then the public right-of-way maximum extent practicable process, the MEP process, doesn't apply, right? You're not disturbing any right-of-way, you don't have to worry about this. There's another situation if you're doing a voluntary retrofit. For example, if you're doing a bioretention in the public right-of-way for the benefit of the neighborhood or for generating stormwater retention credits, then the maximum extent practicable process doesn't apply to that either. There's public right-of-way disturbance when it's limited just to trenching for utilities, driveway aprons, and minor disturbance, so less than 50 square feet. So if you have just trenching for the utilities or any of these other situations, that disturbance is exempt from the public right-of-way requirements for the stormwater management. And also, if there is disturbance of new public right-of-way that was not previously public right-of-way, that is also a situation where the MEP does not apply. In those cases, you have to meet the full stormwater management requirements, right? You don't get this benefit of using the maximum extent practicable process. So the idea with the maximum extent practicable process is that you're trying to achieve as much stormwater retention as possible, as much stormwater management as you can within the acknowledgement that there are conflicting uses of this space, right? So you don't have to, it's sort of an exemption from having to manage the entire swerve or stormwater retention volume on the site for the public right-of-way. But you have to maximize, and the way you maximize is by maximizing the BMP placement, maximizing BMP sizing, getting innovative by integrating the green and the gray. So that example of a tree pit, bioretention tree pit, where you're combining a bioretention with an underground or under pavement storage. Minimizing impervious widths, right? You don't have to have the entire public right-of-way all be concrete. Even if you can't put a BMP in there, try to reduce the imperviousness that you're proposing in those areas. And maximizing the land cover types that don't have as much stormwater runoff, right? So compacted cover area, essentially. Maximizing the tree canopy. So this refers to both planting new trees and preserving existing trees, right? We are highly encouraged to preserve the existing trees that are there in the public right-of-way. Use impervious surface disconnection where possible, and manage the stormwater runoff from the roadway. So you don't necessarily have to control runoff from the development parcel that's running into the public right-of-way area, or just the runoff from the public right-of-way area that you're disturbing in your project. You can also bring runoff in from the adjacent roadway, treat that runoff, and that contributes towards meeting your stormwater management requirements in the public right-of-way. Permeable pavements for low traffic roadways, shoulders, sidewalks, on-street parking, wherever it fits into the streetscape of that section that you're considering. And then BMPs integrated into traffic calming measures is another way. So these are all approaches and things that must be considered, and demonstrating that you are considering all of these possible avenues for maximizing stormwater management. That's what the basic principle of the MEP is. So the process is, first you're going to do the same thing as you would on the private development parcel, is you're going to calculate the stormwater retention volume that's required, the swerve. So that's going to be your target. Then you're going to prioritize, as I mentioned, managing that roadway runoff. So you can take in runoff from even outside the area that you're disturbing, and then get that roadway runoff, which is highly polluted, and treat that. That's the really a great approach to achieving your swerve within the public right-of-way. And then placing, sizing, and designing your BMPs to maximize retention. Right? So the Stormwater Management Guidebook, Chapter 3, BMP specifications, and as covered in the other videos in this series, are applicable, but the DDOT LID standards are also applicable. So make sure you're checking out the DDOT standards as well. They're generally consistent. So let's look at an example. So let's say we have a corner property with some adjacent public right-of-way. It's just sidewalk, so a 10-foot adjacent sidewalk, 200 linear feet. The swerve for this is going to be 1.2 inches, because the public right-of-way swerve is also always calculated at the 1.2 inch precipitation depth. So multiplying that by the 100% impervious sidewalk, so you've got the 0.95 coefficient multiplied by the 2,000 square feet of sidewalk, converting to gallons, you get 1,421 gallons of our stormwater retention volume. And so that's going to be the target that we're looking for in this design exercise. Oftentimes in the public right-of-way, in such a case where it's just under existing sidewalk, you have poor infiltration, but oftentimes there's a storm drain available in the adjacent street for under drain connections. So let's use these assumptions for this case. So here's the development parcel we're talking about. So in teal there, the development parcel, and then that 2,000 square feet of adjacent sidewalk, the green area there, that's the public right-of-way. So we're going to look at what conflicting situation we have and what we can do in this area. So first, let's look at our constraints. So the ADA crossing requirements right at that intersection, there's not a lot you can do in an intersection, right? You have to keep those areas clear. So that yellow area, we're not going to consider for stormwater management. Driveways, so into and out of this development parcel, you're going to have some driveway aprons. Not much you can do in a driveway apron. A bus stop, so another conflicting infrastructure that you have to work around. The building exits, so there are requirements on space of being left for free exit of the building, and then the 5-foot width of sidewalk, so the passing of pedestrians in those areas in brown there, so we can't do much in those areas. And then utilities, so you can see these 4 utility lines coming out of the bottom of this development parcel here. So that area in brown, can't really put a BMP in there. And then there are some existing trees. So 3 existing trees are shown over here. So you can see quite a lot going on this adjacent public right-of-way to this project. So really the only area that's left for actually installing a BMP is down in the bottom in that dark blue. We're going to propose a bioretention. So we can put a bioretention into that area and get some stormwater retention value from it. Permeable pavement could be considered in these sidewalk areas. The trees, the utilities, and the bioretention area kind of not make a whole lot of sense to do permeable pavement because that sidewalk is going to be draining into the bioretention anyway, so it's a little redundant. And then you don't want to put a permeable pavement over the utilities, and then probably don't want to disturb the root area of those trees. So it may work in some cases, but in this case, it's a bit redundant and excessive. The swerve achieved based on what we just showed, you can see for those 3 existing trees, we're going to preserve them, right? You don't want to knock down a tree and put a bioretention where there are existing trees. So you get the 20 cubic foot retention value for, these are large trees in this case. So there are 3 of them times 20. Converted to gallons, you get 449 gallons of retention from preserving those 3 existing trees. The bioretention area was 220 square feet. Generally, bioretention in the public right-of-way has shallow ponding, so the calculation ends up being 823 gallons of storage provided. As we mentioned, there's poor infiltration, so we've got to put an under drain and connect it to the storm sewer. So you have to multiply that 823 gallons of storage by the 0.6 multiplier. So we're achieving a retention of 494 gallons from that bioretention. So the total swerve achieved here is 943 gallons, which has not met the required swerve, but the MEP process has been followed. There's another thing you can do here. So we had the utilities going through the sidewalk area, but the utilities shouldn't have a bioretention over them, but they don't have to be covered in impervious cover either. So if you take out that impervious cover area and make it turf or some other landscaped area, you can use that compacted cover. So now instead of having 100% impervious area, you have 16% of that area as compacted cover. So that reduces our target swerve to 1,254 gallons. All right, so down from the 1,400 plus gallons that we had before. So now by reducing the impervious cover, we get that swerve required and the retention achieved a little bit closer together.